Um, so steps to replicating. First, of course, you had to plan out the build. Then you had to get the hardware. Then, of course, you got to build it. When planning out the build, I already had the processor. I had the water cooler, and I had the SSD that I decided to put inside of it. So I got the motherboard from a friend. I had to source the RAM off of Reddit, and as well as the power supply. So it took a while to get, but of course you would want to build your computer based around whatever needs specific. So this being a server class, I wanted to maybe build something that could be a incognito server, right? And I already had half the parts kind of laying around, and I had a friend who had a non-working computer. He told me he'd give me his motherboard and his graphics card so I could continue to actually do my project without spending too much. And so yeah, that worked out. That backpack right there is the backpack I'm using. It's called the Targus Drifter 2. It ended up just being a backpack that I had laying around, but it had some really good benefits to it while building it, and I'll express those while we're going through the presentation here. So we're just going to go right away into starting like the steps as far as how I built this computer here. So I wanted to obviously have the motherboard on something that wouldn't be conducting static electricity and something that is really stable. I chose to do wood for this. This was 1/4 inch thick. I cut it just kind of a little bit, half an inch smaller than the actual size of the second pocket where I wanted to put my motherboard. I wanted to put the motherboard up against a patch inside of this backpack that was already there. That was a thick spot. That was one of the pads for a laptop to originally go in. So I put it flat against that, and then that thick spot of the laptop holder was enough for me to actually put screws in through the other side, and it was what allowed me to actually mount it in and hold the wood, and you'll see that a little bit later. This picture is really noting that it was really important to get these motherboard standoffs level as possible, because you don't want your motherboard to be bending inside the backpack. It's already scary enough, it's going to be moving quite a bit, so as level as you could get those. I just kind of put the motherboard on top of the wood. I lined up the holes. I had already previously cut the board, as well as I knew I had to use a micro ATX sort of a build for this. If you had a bigger computer though, even this computer, honestly, I think you could have fit a full-size ATX motherboard in it. It would have been kind of crammed and hard, but I think you could have done it. This picture is showing how I wanted to have quite a bit of structure that wasn't just based upon the computer components themselves. I understand that a lot of computer companies, they make understanding that consumers, they're not going to be the most careful with their products, and a lot of consumers themselves don't even really understand the safety protections on a product or the wrong ways to be treating a product. So if you haven't built your own computer yourself, you should definitely do it, because it's nothing to be really too scared of. So for structural support, I ended up using coat hangers that I unbent, of course, and then I put them into the lining of this backpack here, and you can feel them in certain spots, and that's just to kind of keep the backpack out and away from the computer components. So this was that plate I was talking about earlier. This is the second pocket of the backpack there, if you're looking. At this point, I had to start cutting out quite a bit of material from the inside of the backpack. I'll talk about more of that later. However, this is the back of the padding here. So this was pretty thick. I'd say probably 1/4 inch thick itself, and it ended up being really good structure to have my wood up against. And then on the bottom of the backpack, there's actually another reason why this backpack was so nice for me. It had a built-in piece of really thick plastic that stays at the bottom of this backpack, which allows it to hold its shape at the bottom as well. So even if that wood were to kind of sag down a little bit, it would just kind of be hitting that piece of plastic, and it ended up being fine. So I secured it with quite a few screws there. Next part for securing was the power supply. Obviously, you're going to want power supply to have good enough cooling. This power supply ended up working really nice for me because it was like a form factor power supply. You can kind of tell because it has that 80mm fan right in the front there. It wasn't like a regular power supply that you might go out and build for a gaming computer or something like that. I didn't look at the fan properly right away, and so I did cut a vent hole in the back of this backpack because I was preempting the fan to be there. However, it ended up being in the front, so I just had to make this hole there. I ended up cutting a little bit bigger, and if you look at it now, it's quite a bit bigger to actually properly have the right ventilation for that power supply. Not too worried about power supply overheating really, however it is concerned. I also did want to have it quite a ways away from my other components. just because I know it can put off heat and stuff, and this is obviously something that you have to watch being inside of cloth. And so once I had the power supply in, I wanted to figure out, where I was going to put all the components, and a lot of this I had to kind of figure out in my head. The orientation of the motherboard, of course, was really important when you even lined up the standoffs to begin with. So I knew where I was going to already have my 24-pin connector for the power supply. And then I kind of decided I want to have my hard drive separated from the other components so they wouldn't also be contributing to the heat factor. So I did end up routing a cable through a lot of different pieces of fabric that I cut all the way up to the front pocket of the computer. And you can see there's a hard drive and an SSD up there. Here you can see a lot of the cutting that I started to do at this point. I knew I was just going to need to kind of put in my motherboard after this, do my graphics card if that's something I wanted to do. So I wanted to make sure that this computer had proper ventilation to put in a lot of fans that I did have as well. I told you I wanted it to be discreet as possible. So one of the nice things about the mesh right there is I was able to kind of cut right behind the mesh. You can't really even see through the mesh. If you look right here, there is a radiator sitting right here, which is fairly hard to see, being that this mesh was here to kind of cover it, making it very discreet. I like that. I ended up cutting out the other side as well for another 120 millimeter fan that ended up being a 140 millimeter fan that I thought I was still going to be able to fit, but unfortunately it was just a little bit too big to be fitting, and so I kind of compensated for the heat by putting in this really big 200 millimeter fan to just kind of just put that heat at due. These pictures aren't as clean as the actual finished product. I noticed I wasn't happy myself with how sloppy a lot of the cutting was, so I did go back with a really nice knife and I ended up cleaning up a lot of the different cuts. I think that really does contribute to building up the dust if you did have this running for a while, or the heat factor would contribute to as well. And so then I wanted to have this water cooled. And I didn't think it would be easy to put it in while this motherboard was seated on the wood. Obviously, you have to put the back plate on the other side of the motherboard. So I had to seat my cooler on there. Now this cooler I had sitting around for quite some time, I'd say like a year and a half. And so I put it on there, and I thought about the orientation of where the pump was originally. I knew I wanted the I/O of the motherboard to be towards the top part of the PC, and originally when I had done these standoffs, I had made the I/O flush with the edge of the wood, and so I thought about kind of where I was going to have the pump and then where I wanted to actually put the radiator. Upon first putting it in, I realized how low the amount of water was inside this pump still. It is a singular loop, and like I said, I had for a while, so I ended up emptying it out and redoing it with distilled water, and then so I had to redo thermal paste again a second time, and then after I had redone that thermal paste, thermals were still not kind of where I wanted to, so I had to end up taking everything out a third time and redoing it again, but that was just so I could have it somewhere where I actually felt comfortable where the temperatures were. So then after I had it mounted outside, I went ahead and put the motherboard in. And then I properly seated where I wanted to have the radiator, as well as putting on the fan for the radiator. This radiator is pulling air in through the bottom, and then this 200 millimeters venting air out. I wanted to have it, like I said, the other 140 putting in air from the other side, but that just didn't end up working. So I put the video card in at the end to possibly move around a little bit more air in my hopes, but it might end up just heating things up a little bit more. I haven't been able to do too many benchmarks with the video card in. And then, these were just kind of the last finishing touches. I was able to put in the hard drive in the front, as well as that 200 millimeter fan that you saw. And that was for looks as well as cooling. So if you look, I don't know if any of you have ever used 3D Mark. It's a software on Steam. They do a whole bunch of different benchmarking services, and then they compare them above a national database of computers. And so, it assigns its own score based on whichever benchmark you do. So you can see kind of where this PC was scoring. I wasn't originally building this to be a gaming computer, but he gave me the graphics card, and I said, why not? It's part of proving the point that it can actually, keep up with that type of temperature. So it said, they did 24% better. Did 24% better than most PCs, as well as this was a stress test run by IDA64. This was originally when I didn't have the graphics card in, because I just did that most recently when I applied the most recent thermal paste. But here you can see that CPU temperatures after 20 minutes, they weren't exceeding anywhere above, I think it was 68 degrees Celsius. That is a little bit hot. The CPU, its shutdown temperature is around 85 degrees Celsius. But remember, this is under full load. So this isn't necessarily replicating, if you were running programs or playing games, because it's very not often that you would have a PC or a CPU under full load like that. But it does happen at times. So then just some things to compare as far as this computer based to a regular computer. Like I said, there's the thermal issue. This being made out of cloth, it's not going to be putting out heat as much as like a regular case, something like that. That's why I wanted to make sure I really had lots of airflow throughout this whole case, as well as having that wood back there so it wouldn't be against, just regular cloth. The size constraint, there's lots of different size of backpacks out there, so I'm sure you could have a backpack that would be big enough for anything that you wanted. However, like I said, I did want this to be discreet, and so I think, compared to a regular PC, you can't necessarily make it a 4-foot tower, but you can work with what you got as long as you're creative and can kind of engineer around it. And then stack electricity. This was something I was kind of worried about myself, and I did a little bit more research on, and this is another reason why this backpack was so nice for me. The bottom of this backpack actually has, they call it their weather guard. It's a piece of rubber that's on the very bottom of it. So that was, going to prevent any fabric on the bottom, gaining static electricity if it was rubbing on some sort of a carpet or something like that. But as well as the outside of this backpack is made of all nylon materials, not all of the inside, but all the outside is made of all nylon materials, which is non-static, non-electric conductive material, unless it's wet, but it's also water resistant too, so that was a little bit of an added benefit in that side. So yeah, I built it and it ended up working out real nice. In the future, if you wanted to carry this around there's plenty of room, to put in a portable power supply in here, something like that. In the back, there's still a whole bunch of room, so you could theoretically make this a very portable backpack laptop, I guess. So, yeah. Any questions for me?
Is this presentation not running on that guy right now?
Yeah. That was part of the point to prove, and then the last point to prove as well is I was going to put it on my back while I was running to show you just how structurally secure I am with it. So theoretically, I'm blaming on the connector because I didn't screw it in. But theoretically, you could be walking around with this computer working.
So it's a business application.
Right. Sure. I think a main part of it, is just how discreet it could be as well. If I had this all zipped up, you can have this zipped up as well. The only real main part that you'd be able to tell is if you're really looking at this power supply at the side, and that's something that you could also, if you just put like a little mesh sheeting over, you can definitely cover up there. Yeah. Any other questions? Go for it.
How heavy is it?
I don't have a scale, but I'm gonna say probably lighter than your backpack that you have right there. It's like 12 pounds maybe. I don't know. It's not that heavy, I would say. Yeah.
Can it run Crisis?
This isn't only a dual core processor, but it could maybe do it. I could see it doing it, yeah. I have Crisis, we could have downloaded and tried to get around it. Yeah.
How would you compare it to like the school laptop or a server laptop? Would you use that for like daily use? Or?
The size constraint is kind of, having to have it on your back. I definitely got sweaty coming up the hill. But I'd say it probably does run processes quicker than computer, built in. A lot of laptops themselves, they run mobile processors too, which have their own constraints as far as how many cores they can have and how fast those cores work. So, I understand this wasn't going for a laptop. I don't know if you've ever seen Intel's new Nook that they just released. It's really small. It can fully run VR, and it would definitely, take up something like this as a spot. But if you have the parts sitting around, is it practical? Sure, I guess.
Any other questions? Thank you, Tyler.
Nick Nelson, Dakota